After dark. What's up? Are we beatniking?
Oh, you can't hear it, can you?
No. Oh, yeah.
Go on the microphone.
Well, yeah.
Clapping along to the After Dark music.
Oh, I mean, kind
I
of.
like how I can snap my fingers with my right hand, but my left hand's like, nope.
That's
really?
No, dude.
You should get that checked out.
So,
Wow.
yeah.
You're so weird. God.
Snap on my left.
Kidding.
Space Mike, let's do your pod real
Do
quick.
the pod.
Oh, yeah.
Yeah.
Do the pod.
I want to go to Space Up Seattle.
That'd be so.
Yours is Mars helicopter, right?
Helicopter.
Okay.
Yes.
Ready when you are.
Tuesday, May 15th, 2018. Official NASA Slate. Okay. It's official. NASA is sending a helicopter to Mars, a small one and a robotic one. And it's going to be complementing the Mars 2020 rover to collect more data while at Mars. This is your space pod for Tuesday, May 15th, 2018. Not only will this vehicle demonstrate the viability and potential of heavier than air vehicles on the red planet, it will collect valuable science as well as some awesome imagery of the Mars 2020 rover. The project was started in August of 2013 as a technology department project at NASA's Jet Propulsion Laboratory, or JPL. The result of the team's 4-year design, testing, and redesign weighs in at a little under 4 pounds, or 1.8 kilograms. Its fuselage is about the size of a softball, and its twin counter-rotating blades will bite into the Martian thin atmosphere at almost 3,000 revolutions per minute, about 10 times the rate of a helicopter on Earth. The helicopter also contains built-in capabilities needed for operations at Mars, including solar cells to charge its lithium-ion batteries and a heating mechanism to keep it warm through the cold Martian nights. But before the helicopter can fly at Mars, it has to get there. It'll do so attached to the belly pan of the Mars 2020 rover, which is identical to the Curiosity rover. Once the rover is on the planet's surface, a suitable location will be found to deploy the helicopter down from the vehicle and place it onto the ground, and then the rover will be driven away from the helicopter at a safe distance, and the commands will be relayed to the helicopter. And after its batteries are charged and several tests are performed, controllers on Earth will command the Mars helicopter to take its first autonomous flight into history. They don't have a pilot, and the delay from Earth is several light minutes anyway, so there's no way that they would be able to have a joystick controller to do it in real time, at least according to Mimi Ong, who is a project manager at JPL. She said that instead, we have an autonomous capability that will be able to receive and interpret commands from the ground and then fly the mission on its own. The full 30-day test flight campaign will include up to 5 flights of incrementally further flight distances, up to a few hundred meters, and longer durations as long as 90 seconds over a period. On its first flight, the helicopter will make a short vertical climb to 3 meters, where it will hover for about 30 seconds. As a technology demonstration mission, the Mars helicopter is considered a high-risk but high-reward project. If it does not work, the Mars 2020 mission will not be impacted. If it does work, helicopters may have a real future as low-flying scouts and aerial vehicles to access locations not reachable by ground travel on Mars. In any case, the Mars 2020 rover will be launched on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 in Cape Canaveral and is expected to reach Mars in February of 2021. So be sure, if you haven't already, to check out our last live show where we talked with Tim Ellis from Relativity Space, the CEO of Relativity Space. That was a very awesome interview. So be sure to check that out if you haven't already. And every live show that we have every Saturday at 1800 Coordinated Universal Time. Until the next time I see you guys, though, keep on moving onwards and upwards. And don't forget, Ad Astra, to the stars.
Can you redo the close with like and subscribe, please?
Oh, dang. Forgot that part. In any case, be sure to check out our last live show where we talked with Tim Ellis, the CEO of Relativity Space. And that was a very interesting interview. You don't want to miss that one. And be sure to also check out every live show that we have at 1800 Coordinated Universal Time every Saturday. Be sure to like and subscribe and hit the bell so that you get plenty of notifications whenever we go live or have a new video posted. Thank you very much, everyone. And keep moving on. Messed up right at the end there.
Almost had it. Almost had it.
Almost. So close. In any case, be sure to check out our last live show where we had an awesome interview with Tim Ellis, from the CEO of Relativity Space. And that was a very interesting interview. You do not want to miss that one. We also have a live show every Saturday at 1800 Coordinated Universal Time. And be sure to check that out every time that we have it. Be sure to like and subscribe and get the notifications whenever we do go live or have a new video posted. And if you're interested in becoming a citizen of tomorrow, you can also support us at patreon.com/TMRO. Thank you very much, everyone, and keep moving onwards and upwards. And until the next time I see you guys, don't forget, Ad Astra, to the stars.
Yeah, cool. Thank you.
Whew.
You are free to
You
go.
can throw in Patreon in there. I forgot that before.
Thank you. We'll see you next week.
All right. Thank you very much. Great show, everybody. Good job. Today was great.
See ya.
So we'll see you again. Thank you. Bye.
He got it. He got it.
Yay. Hold with it.
I just like snapped my wrist. That hurt.
Whoa.
Arthritis.
Hi.
There we
It never
go.
ends.
Into the infinite.
ends.
Beyond the infinite. So
I'm gonna take a picture
cool.
with my laptop of that.
There's
photo
another
booth.
stool out here, Dada.
So, by the way, that I just since it didn't get mentioned, but it was mentioned in the chat room, they have tested the Mars helicopter.
Oh
So,
yes.
Yeah, it's been tested at pressure in a vacuum chamber, and it flies. So
That's awesome.
yeah.
Woohoo!
That's really fun. You have to get the rotors to spin at 50 times per second, but you have to also keep the rotors subsonic.
Whoa.
So
Wait, subsonic
sure,
versus
yeah.
supersonic.
Yes.
Subsonic is just below the
Yeah,
reaching
just below
Mach 1.
supersonic
Okay,
speeds,
right
yeah.
below it.
So-
Oh.
supersonic rotors don't really work all that well.
Oh. Wait, how fast do they move then? If they're like, are they just like very like right below borderline of like the speed of sound?
I guess.
Yeah, I don't know what they are. I'm gonna look it up.
I have to do the math.
Subsonic. Subsonic speeds. How's it going?
Good, good.
Yeah,
How are you?
good. Looking up subsonic speeds.
Nice.
Yeah, it'd be just
On
below the
Mars?
speed of sound. On Mars, yeah.
Yeah.
It's like 343.2 meters per second.
Oh, that would be different. The speed of sound on Mars.
Wait a second, it would, because
the atmosphere's a
different.
lot. Yeah.
Yeah.
Oh gosh, yeah, I'm not calculating that, sorry. Like, wait.
All right, that's enough
You
math
guys
for
can
one
totally
day.
calculate it.
So,
Yay!
Nice.
This is cool. Dude, that took like so many takes before. It was so weird. So it's like just having to do it over and over and over again. Sorry
Yeah.
about
Don't
that,
you have a
guys.
space
I'm
pod?
sorry.
I do.
to do.
You do have a space pod, yes.
I do.
So,
I
do we
think
need to bail on?
They had a bio break. What?
What's up?
Okay.
Did we have more questions from Tim?
Oh, I'm
Tim?
excited for yours. Well, I guess I'll hear it when you go. I was gonna open the script and then I'm like, let me just
It's
wait.
nothing like super. This happened. It's more like, oh, a couple fun scientists said some
Right.
fun things.
Yeah, I saw that
that's
happen.
amazing.
I was,
Yeah.
I had a actual day off on Monday,
Wow.
and I was just
Whoa.
looking at Twitter, and I saw like the scientists
And?
started becoming like there were insults hurled at people, and it was like,
Oh my
it's
gosh.
Flinging. It was.
I
It was
mean, like
savage.
I've said
Yeah.
that at conferences, like fisticuffs have almost happened
So-
due to Pluto.
Oh my goodness! And you know, Grinspoon and Stern are going to be at the observatory next
Yeah,
Wednesday.
they are on Wednesday.
Are you going to be there?
I am there,
I wanna be
so
there.
I am helping with that.
Nice.
So
I
might
I'm,
visit.
I'm the muscle to help keep.
You always
no, I'm
are.
just kidding.
You always are, Jared.
So.
So rad.
Yeah, so I guess we're gonna go back with Tim.
Yeah.
And we're gonna. If you guys have more questions for Tim, now's the time
I have a question.
to do this.
What was the first thing you ever 3D printed?
That's a good one. At
like at all, or
Ever.
relativity?
Ever. And then relativity, both.
Ever.
Curious.
Oh man, I'll actually have to think about this. Yeah, so the first thing I printed, it was actually like a functional part. It was at Blue Origin, so I probably can't say what it was.
Oh, okay.
But it was really cool, which I know is such a tease. But yeah, it was just like a super complicated part, but we actually like tested it. And it worked, and that was part of then like selling, like, okay,
Yeah.
you know, we should actually do a lot more of this, like in-house, and like go get, you know, some 3D
When did they
printers and
first
stuff.
start doing 3D printing for like, rocket parts?
Yeah, that's another one. I don't want to talk too much about Blue
Okay,
Origin,
I mean, not
only
Blue Origin, I
because
mean, okay, what about relativity space?
Relativity. Yeah, so then the first thing we printed there, it was also like, it was just like a full engine, like injector
Wow.
chamber. That was like the first thing we made.
That's so cool.
We actually cut it in half, and then like, you know, that was part of the fundraising part, right? You like
Yeah.
make an engine, like cut it in half. You like can show people, you know, hey, like this would normally be like hundreds of parts, and like look at how crazy complicated it is.
Yeah.
It, you know, looks like a cathedral. It's like kind of
That's so crazy.
SSME style, you know, like design and things.
Right.
And then yeah, just being able to show that, like a lot of people haven't like even seen like what metal 3D printing looks like. And so seeing it, you're like, holy cow, like this is pretty amazing.
It's so intense. They're so heavy too.
Yeah.
That's so cool.
Totally.
And the room's lighting up.
Yeah, there's a lot of questions in
So,
here.
from Andrew Shire in our chat room, Tim, what's the resolution of your 3D printer?
Yeah, so resolution, we could get a lot into like resolution versus accuracy versus like, you know, that's always like what's the spread, like how accurate is it? But yeah, I guess what I can say is we have, you know, like one of the nice things is because we're building and designing our own rocket that like we're not making parts for other people, so we kind of control like what resolution we need in a sense. Like, you know, if it's slightly too big or slightly too small, you kind of can like make adjustments to like use that rocket for like a slightly like lighter satellite, for example.
Nice.
But yeah, we've already developed it to the point where, like the resolution, it's kind of like lower, but you can build much faster with the large aluminum structures with Stargate, but then much higher for like the engine parts and like valves and things like that. So.
All right, cool. Yeah, let's find some more questions amongst the multitude of them. Twicked is asking, why can't you print bearings? Is the resolution not high enough?
Yeah, so turbopump bearings are probably the highest tolerance part on like a whole rocket engine. I would definitely believe that. So normally even the bearings, they're not even machined or anything like that. I mean, they have this like extremely specialized process because your turbopump spinning at between like 30,000 and like 70,000 RPM, which is like several hundred like revolutions per second. I mean, it's like actually unbelievably fast.
Yeah.
And then the bearings help support that. So one thing you could print is actually what's called like hydrostatic bearings. So that actually doesn't physically contact with like kind of like ball bearings. You actually use a fluid like propellant kind of in between, and the shaft like kind of rides on like that fluid bearing. So that like could definitely be 3D printed. It just takes more development, and we would maybe do that like later on, but not for a first turbopump.
Yeah, and to combine two questions from our chat room. One from Neuropilot, which says, will you make parts for other companies under contract? And then second part of that question from Hannes Vorwerp in Twitch, which is, are you going to support yourself by making rocket engines for other companies, or are you just using VC? So I guess, are you going to make parts for other folks? And if you do, will you use that as funds?
Sure.
So.
So the answer. So we definitely get hit up all the time by people that like want us to print like other things. Which it's like that is actually very exciting. But what we're more excited about initially is we're actually also seeing a lot of customer interest for just launching satellites. And we want to make sure that we're having really good customer service and actually like going after just a more focused set of companies first. And so launching satellites is like really the first focus for now. And as far as selling engines and that kind of thing, it's kind of similar. Like we just think of fully vertically integrated product line where we're just launching satellites. It's kind of like the best thing to do, and we can keep using like venture funding. You don't want to do that forever, of course, though.
Yeah.
Like eventually you want to just be like doing launches,
Exactly.
like scaling up, doing more, and just kind of have it be sustainable from there.
All right, and then another one from the chat room, Zwebby, which is with your plans for automation, because you do have plans for automation.
Yeah.
Are they at a capacity level to make multiple rockets at the same time?
Yeah, like multiple designs, I would assume. Well, yeah, if it's multiple designs, like the whole point is there's no fixed tooling. So like each kind of version of the rocket that you do like can have better and better features. Like I think even Elon and SpaceX, I think, recently said that like most of the Falcon flights to date, except for now Block 5, like had little changes and improvements on every single one. And so we would actually be able to do the same thing, but with fewer people actually like having to do all those different changes.
Nice.
So instead of having 5,000 to 7,000 people like working at our company in order to sustain that level of innovation, like our plan is to use 3D printing and automation to be able to do like that quick iteration, but with like maybe only a few hundred people.
Gotcha. And combining two questions again, because you guys are really good at asking very good questions with this. Travis Neal from YouTube wants to know what, in your opinion, is the best in situ stock to use for 3D printing, and then combining the second half of Travis Neal's with the second half of Tawicked's as well, which is, do you plan to take the raw material with you, or do you expect someone else to provide it, or how are you going to get that raw material for the usable stock?
Yeah, sure. So I definitely think like a logical step one, because this is like a pretty ambitious thing to do that I definitely think is actually like well reasoned out and like definitely possible. But I think sending material there first is probably the best first step from Earth, just because then you're trialing out like the printing, with low gravity, kind of a different atmosphere, and then different atmospheric pressure. You're kind of lucky in that you can actually test those parts out on Earth, and we actually plan to, in like the next few years, actually like do different steps of the printing process that you can simulate on Earth. So send material there initially, but long-term things like aluminum alloys that are actually like pretty common on Earth and like are printable, you can actually make on Mars. Even though it's like red, iron is actually not like the most kind of like abundant material. It's actually more like aluminum, magnesium, like silicon, like those kind of ones are like super prominent on Mars.
Yeah, there you go. Gosh, there are so many things. Rebel Ace Friesland from the chat room. What other material than metal do you print? And have you flown a printed test model yet? Not quite, if I remember right. Not flown yet,
right.
But you've definitely run it a lot.
Yeah,
so.
Exactly. Yeah, not flown, but I would also say that's like specific to like our designs and like the Stargate printed parts especially. But metal 3D printed parts have flown to space at other companies.
Absolutely.
And so I'll just leave it at that.
Yeah. Also, what other material than metal do you print, or is it just metal right now?
Yeah. So right now it is just metal. But what's also really interesting, so since and I can't emphasize this enough, that like printed parts look totally different than traditional. Like you don't just take like a traditional design and like put it in the printer and press print. Like they look way more organic because the design rules are such that you're starting from like a base plate and then have to build the whole thing up. So you get these more like branching structures that like have to kind of all build off of each other. And you want to combine all these parts into like one very complex part. That's actually where you're getting all the benefits. And so because of that, we'll actually benefit from other companies developing plastic printers. Like there's one called Carbon 3D. They do this like really cool process where they just like lift like plastic like out of kind of goo, and it like all melts. It's like cool. It's super cool.
It's like Willy Wonka.
Yeah,
So
yeah.
Rockets.
Yeah, so Yeah. So I would say, check out, like Carbon 3D, like desktop metal. I mean, there's actually a lot of innovation going into both metal and plastic 3D printing now. And so we'll actually get to like piggyback off of a lot of those innovations and just like use them like in our own products too.
Cool. To Wicked is asking a lot of good questions today. Does the printing have real-time quality checking, or will you test the parts later? Will you scrap the prints with minor issues or try to fix them by hand?
Yeah, sure. So right now we do have a lot of sensors that range from just like visual cameras to like much more advanced kind of looking at different like parts of the print process like as we're going along. And we do use those to both control the printer and to also look for flaws and quality checks. Then kind of after it's printed, we're doing stuff with what's called like a SEM or scanning electron microscope. So you're really looking at kind of the molecular scale and like even down to smaller than that scale of like what the grain structure looks like. So you kind of can validate, okay, like the material strength is really good. It's kind of funny because hanging out with like material scientists now, you look at the microscope data and they're like, oh, this is how strong it's going to be. And like as a mechanical engineer background, I'm like, no, just like make a tensile sample and like break it and like show me that it's that strong. And he's like, no, trust me, it will be. And it actually, like the grain structure under a microscope is like almost a better test of quality, and like the whether it breaks or not is actually kind of just the consequence of like what you see under the microscope, which is kind of, I thought that was interesting. It still blows my mind that that's like actually how it works.
So you guys do like non-destructive testing of parts to make sure they're going to work?
Yeah,
Okay.
yeah.
Gotcha.
So stuff like X-ray, like there's that's kind of a traditional method. There's another one called a like dye penetrant. So you can look, that's more for like surface pores and cracks. And then, there's a whole host of like NDT technologies, eddy current sensors, all sorts of stuff that specifically look for cracks and pores. And also too, there's almost always, some sort of like minor flaw, but that's, depending on which part it is, can be acceptable. Like you, in the design of a component, do analysis that's basically, there's a tool called NASGRO. So you're actually looking for what the minimum acceptable like flaw size is for a certain part, and how many cycles you want it to run at, and what the like vibration loads are and other loading. So you can kind of design it such that like even if there's like a few pores, you can tell whether it's acceptable or not.
Yeah. In a really good technical question from our director, Dada, who is a incredibly well-versed, knowledgeable, technical person, asking the tough questions of every company that comes in here, definitely.
That's great.
Which is, can you, during the printing process, insert other materials like helicoil inserts or the equivalent, or being able to bury a high-precision ball bearing somewhere in the middle of a 3D printed part, for example?
Yeah, that's a good question. I know it has been done to an extent. Like, I would definitely not say that's like a very technically like mature way of assembling things. I know it has been done. It's just, a lot of what we look at is like what would the savings or like advantage of doing that be? And if I'm sure there's use cases where like, you could start assembling like things while printing, like that's probably even more in the future. So maybe you're just thinking even further ahead than we are.
You heard it here first, kids.
To Wicked, what do you see as the power source for initial printing on Mars?
Yeah, so actually fundamentally, I think one of the bigger problems, besides the printer, the two ones which people have touched on is like, where do you actually get like in situ raw materials? Just because refining like basically soil like into like actual, or like ore even into like an actual usable alloy will take a decent amount of power. And I actually think, as far as the whole Mars colonization thing, like power generation is one of the things that's maybe talked about less, but I think will become like a really important thing to think about. Just because stuff like solar panels, are great, but like how many solar panels you need for certain energy use can be quite high.
Yes.
And things like nuclear reactors are probably actually much better, but then there's the more regulatory question about that. And so I do think power generation is like actually a very big question, even for like doing in situ like propellant manufacturing, and definitely 3D printing of stuff too, because it all needs power.
Yeah.
There's no fossil
Yeah.
fuels that we know of, so that makes it definitely very challenging.
Yeah. You guys want to grab some stuff from the chat room and
Oh, yeah.
ask a
I
bit
mean, you're
some-
doing
I was
such a
gonna ask
great
about
job
the Mars
wrangling.
one.
no, jump in. Please jump in. I'll just start grabbing stuff that I see.
Yeah. I know the first thing I was thinking when you were talking about Mars is like, yeah, you're gonna need like a really high intensity compressor to even like get that soil to like, because that's
Yeah.
one big thing. And right now is converting some of the soil on Mars and some of the dust
Yeah.
into something that can be recycled and reused.
Yeah.
So let alone trying to even make something for like parts, and get
Yeah,
like 3D
yeah.
printing capabilities.
Yeah.
That's interesting.
Yeah, but 2 more points on that. So
Yeah.
one is like let's say we could like I think inspiring, even if like Relativity is working on like the 3D printers and more the robotics and like control software and like how are we actually going to make things. If we were able to inspire like a mining company on Earth that's like many billions of dollars in revenue because they just do like earth mining, like a Caterpillar or someone like that.
Yeah.
Then if we could inspire them to like come up with some sort of like business case where they can actually make like some of that refining equipment, like kind of local like ore refinement that works both on Mars but then has some sort of business case on Earth where like local refining of ore like in different
Yeah.
countries around the world actually becomes more effective,
Yeah.
then that would make that like accelerate more because then just more money would be going into
Exactly.
developing like for Mars. And also I mean as Earth like kind of gets older and older, like maybe it gets harder and harder to sustain like life on Earth as far as just the number of people and like
Yeah.
global warming and like
Population.
resource like depletion. And so I think actually just even learning how to live in like challenging conditions is probably fundamentally important for keeping Earth alive too.
Yeah, and that's such a valid point too about like actually like getting people on Earth to really care about
Yeah.
it also, because it's like a lot of people are always saying, oh, you're just throwing money into like space, and it's like, well,
Yeah.
actually, if you're giving a huge collaboration, we're making money
Yes.
Yeah.
here on
Yeah,
Earth
exactly.
for Mars,
Yeah, yeah.
and then with the like right now.
Yeah, and I
Opposition.
don't want to be like extremely pessimistic or anything about it, or like really ominous, but thinking about even like Elon has talked quite a bit about why SpaceX is going to Mars is partially to have like a backup for humanity, like in case something inevitably like happens to Earth, like
Yeah.
even an asteroid or something far in the
Yeah.
future. But it's like actually somewhat a self-similar argument because I do. Like, man, I hope Elon lives to be like 150 or 200 years old.
Me too.
But like, if not, like currently SpaceX is like the company I would say really driving the vision around going to Mars. Together with NASA. But like SpaceX is definitely saying, hey, we want to do this on like a giant scale.
Yeah.
And so I think again having more companies working on it actually means like it's statistically much more likely to happen faster. Yeah.
Yeah, that's so cool.
Yeah. And I saw this to Wicked again, on fire with the good questions. He asked, or they asked, do you see in orbit recycle printing, meaning taking scraps and debris and turning them into raws to build what's needed as a possible future revenue option, or will reusable vehicles mean it's cheaper to just send stuff up and burn the debris in the atmosphere?
Yeah, good question. It probably depends on which timeline we're talking about. Like, I mean, I think reusable vehicles for the near-term future, like, together with like automating production. Like, if you kind of look at the economic parameters of getting stuff to space, it's like materials, like operations cost, and then like all the kind of labor that goes into manufacturing and testing. And so reusable, tackles like pretty much like big knobs in that equation, and then automation and like removing the labor from the initial production tackles the other parts. And so with that, I mean, I think in-orbit manufacturing probably has a lot of interesting applications. I think actually in-orbit like refueling of satellites, just so they have longer like useful lives.
Exactly.
That one probably even before like in-space manufacturing, but if you can make stuff in space, then things like really giant, like kind of RF antennas and like huge structures that don't have to withstand like all the G's of launching from Earth. Like, yeah, that's definitely possible. Plus, like, let's just think more sci-fi. I mean, all the movies,
I'm down.
all like movies have these like giant spaceships, like Star Wars.
Oh my God,
anything
the Star
like
Destroyer.
That. Yeah, the Star Destroyer.
Or you even look at the what was it? The newer iteration of the Death Star, which was like humongous,
huge.
like
Star Killer Base.
Star Killer Base.
Star Killer Base.
Yeah, and it's kind of like if you want this stuff to happen, I definitely think like in-space manufacturing is like needs to happen. I know. I mean, Star Trek, they did some manufacturing on ground and maybe assembly in space, but I think in-space manufacturing just like will need to happen to get to the true sci-fi.
All right. Well, I want my Death Star, so I'm gonna have to 3D print it.
Yeah. That may take a while right now, but with a lot of 3D printers,
you can make it happen.
Yeah.
And actually, so this is kind of a cool question I saw a little bit back, but Quadric80 on YouTube asked, and this kind of piggybacks on that, is it possible to print the printer itself for scaling purposes?
Ooh, von Neumann printer.
That's what I was gonna say. I was like, we're going into von Neumann territory.
Yeah, the von Neumann probes. Which is so funny because if we succeed in building von Neumann probes, we may like totally wipe out all of humanity. However, that would be a very successful, that's like hard to do. So it's kind of funny. So print the printer. So we do have metal 3D printed parts on the 3D printer. So we are actually like using metal 3D printing.
Meta.
Yeah. Well, because the printer, like we're still developing certain parts of it, and you want to like change the configuration of where cameras or sensors are, like how the melting process is working. And so those are all 3D printed parts because we can just make a new one pretty fast.
That's so cool because like that really is kind of starting to edge on the verge of like sci-fi meets reality because it's like a self-building robot essentially. Like imagine like cyborg humans who are like, oh, my arm fell off, and just build another one, stick it right back on. But yeah, that's neat.
Yeah.
That's awesome.
That's some cool stuff.
What?
Let's see. I'm trying to figure out if you can talk about this from our chat room. Stratty is asking, what are your power requirements for the printer itself currently?
Yeah, sure. So it does use a lot of power. Like it's on the order of the entire building's power that we're in currently. Like,
gotcha.
Which we we picked the building we're currently in. One for a very tall ceiling. So it's also the printer volume currently could actually be bigger than it is. It's actually sized to fit in the building.
Yeah.
So it's about 24 feet tall and 50 feet wide. So it is,
That's
the
big
big robotic arms, it's like really, really huge. The print volume's smaller, but the machine is giant. And we're like maxing out the power grid, which is quite cool. It's just
that's an accomplishment.
Well, it's like lots of electricity, 40 volt into like rocket parts.
It's very Tesla-esque right now.
Ooh,
Nikola, by the way, not the car.
Yeah, Johnny Boy.
Not the car.
Johnny Boy has an excellent question, which is, do you plan to test 3D printing in a vacuum?
In vacuum. So I wouldn't say hard vacuum, like we were kind of talking about earlier, as we get closer, both to like launching our own rockets on Earth, but then really thinking about, okay, like what 3D printer are we going to design to like go launch to Mars? That you want to test a lot of that environment on Earth, so you can actually use like simulated Martian atmosphere. I mean, that's actually really easy to make. It's just like gases blended together, and then you want to test like simulated Martian pressure, which is a little harder because it's very, very low pressure, like I think on the order of fractions of a psi, and so that needs to be in kind of a vacuum chamber like thing, but not quite full vacuum.
Cool.
Yeah. And so cold, cool. Very cold.
Yes. Twicket has an interesting one that I want to pull, which is that with so many rocket startups, have you faced skill shortages when hiring new people?
I would definitely say not, actually. Like We have a really, really, really good team, and we've been able. So one of the things, I guess, it was during the interview, but you talked about what's it like to be a startup. So one of the parts of it, in order to raise, this like $45 million in venture capital. So part of it is there's like stock in the company. Like kind of talk to any SpaceX like early employee, and they're like pretty happy that they like got ownership in SpaceX because now they're a $25 or $27 billion company. So it's worth like a crazy amount of money. So same thing with us. Like we actually give people that join like ownership in our success, which as we like get bigger and go along and are worth more, then that actually incentivizes people that are really, really good to want to join. And then once you have like good engineers on your team, like more good engineers want to come. And so we've definitely been super fortunate there.
It helps to do cool stuff too.
Oh yeah,
cool stuff is definitely like I want to go do that.
And to be clear, like the other stuff we talk about much more is like, okay, this is a side benefit, but reality is we're like, hey, do you want to work with like rockets and robots and 3D printers and like, and most people are like, okay, that's cool. Yeah. I mean, what company is actually doing like our first purchase at Relativity was a robot arm, and we have I mean, how many robot arms do we have now? Like almost like 12 or so, with more on order, or like those are including more on order. And so it's like we actually have more like robots than we even have like rocket engines yet, which I think is like quite cool. It's kind of like it's like Tesla for rockets, I guess, of sorts. Yeah.
Cool. Fit Orion from Twitch has a cool one, which is, what environment do you print in? Do you put them in a vacuum chamber? And I think that's
sure.
You probably just print in a regular environment, right?
Yeah. So actually, there are people that do big 3D printing like in vacuum. The issue with that is like kind of the forces on the vacuum chamber scale up like enormously the bigger the enclosure gets. And so we're actually designing our printer to not just do even the scale we're at currently. Like we can actually we're designing the kind of approach so that we can add more robots and actually have like a bigger printer, like even more robot arms. So like for example, at the current deposition rates we're like doing like for our own rocket parts, if we were to do something as big as a Falcon 9, but just like more robots on a bigger diameter, it would still only take 30 days to build a whole Falcon 9 like structure, which is like obscenely fast and very, very cool. So it like that's because we are not using a vacuum chamber. We have like local shielding gas, which helps kind of protect the weld from like, welding and 3D printing are somewhat similar. So it protects it from oxidation and makes sure the material like solidifies properly.
Wow. Loopy Dragon from YouTube asks, do the robot arms have names?
Actually, I don't know what they are because, that was more of a Jordan question for you probably, which is my co-founder. So he wanted to name them after like technicians. I was like, come on, man.
StarCraft names, but
I'm sure there's StarCraft names.
More StarCraft
well, I think
names.
I saw another question of like, we kind of joke like, must construct additional pylons because we're running out of power like in our building, right? I mean, there's some good fun stuff to do. But,
Nice. Yeah, names are always like the funnest part.
Oh yeah. Names and logos. Logos are good too. Yeah.
Oh yeah.
I guess speaking of logos, Techweed, how did you guys pronounce it?
Tewicked.
Sorry about that.
That was so great the other day when you were the other week when you were like TWKD.
I'm sorry, I know,
such a new mistake.
They're fuming right now. So. But that's what we always like. We always like Tewicked when they're fuming. So, anyways.
Tewicked asks, and finally, any plans for a merch shop?
Oh man, I mean,
fun.
I'm sure.
Yeah, because you're mentioning logos. So I'm
it
like,
makes sense.
Okay.
Yeah, I mean, we have a lot of swag. It's actually pretty cool. Like, we just made this T-shirt that literally was like Stargate, like the robot arms, but like on Mars' surface, like with a rover, and there's like sunset of Earth on the background. And they're on the back. It's like it's really cool. Yeah, it's really cool. Yeah,
I'm gonna look that up.
Yeah.
That's so cool.
Yeah. I'll have to send a picture to you, and we'll have to like do a merch thing or something.
Yeah.
I guess to kind of throw into this,
I don't know.
Destructor 1701 is asking ITAR, are you a fan? And also, someone was asking too if people who are out, if you guys are planning to go international eventually with your company as well.
Sure. So ITAR makes going international challenging, definitely. So, that would, really for us, that would be either manufacturing rockets, internationally, or, flying at some international launch site. And in order to do that, you have to do, lots of different agreements with, the Department of Defense and all sorts of, U.S., regulatory agencies. So I'm not, looking to do that anytime soon. But, am I a fan of ITAR? I mean, on the one hand, yes, it definitely makes stuff more challenging, but I totally get why it's there. I think, and we're definitely very serious about kind of the security of what we're doing and making sure that we follow it because, 3D printing rockets, it's you can make rockets really quickly. There's other kind of, interest in what that could be used for, and so we want to make sure that that's just American.
And for launch sites, are you guys thinking about anything specific?
Yeah. So we actually plan by the end of this year to have a launch site under contract.
Oh, nice.
Yeah. So that'll be exciting. So we're looking at all the major. I can't talk about specific places yet, but we're looking at every major U.S. launch site. So that's Florida, both Air Force and NASA side of the Cape. Georgia, Wallops, Alaska, and Vandenberg Air Force Base.
Very cool.
And so, it'll be exciting to have a launch pad. Once we have that, that's the last major piece of infrastructure then before flying, right? Because we have all the test and development.
Are you going to 3D print your GSE, or ground support equiment for that? Or have you guys thought about doing that with it?
We've joked about it, but I don't think there's any way we're gonna.
That stuff's really difficult.
It's just super heavy, and there's not necessarily a benefit because it's really the things that fly that you want to be super lightweight and high strength. Ground support equipment usually is just pretty beefy.
Gotcha. Cool.
Some more questions here.
Yeah, I think you guys grabbed one.
Yes, from Travis Neal from YouTube. He says, here's something for Tim. Why are tech and space startups all about the engineers and no MBAs or BAs? I don't dispute the priorities, but just notice the obvious omission. The MBA.
Well, MBA is probably a business degree. So So actually, one of the guys on our team. I mean, we have someone that previously worked at SpaceX, and then before then an investment bank, and he has an MBA. We actually have several MBAs, and they're engineers, and they're just super passionate about space travel, and they have the financial skill sets to do a lot of the modeling and help us look at the market very quantitatively, and all that stuff is still super important. So I would say. Yeah, and then also, me too, I'm definitely a super hardcore engineer in background, but you learn, when you have to raise $45 million, you learn pretty fast, how financial transactions work, and you can still use an engineering mindset for business too.
Exactly.
It's still there's still design requirements. So you can still think about things the same way.
Good point.
And same even with building teams. What skill sets you need. How are you going to vet people? It's
Exactly.
all kind
and
of
that's
related.
so important that you mention that too, because obviously when it comes to building a rocket, there's an immense amount of technical knowledge that you and know-how you need to have. But there's so many other factors because it's such a three-dimensional and kind of dynamic thing. Like you said, everything from management to financials to, you really do have to become somewhat of a Renaissance man. Just kind of know everything.
Yeah, getting a launch site and, all the FAA launch licensing and regulation and, getting customers, customer contracts,
Exactly.
those are usually pretty intense legal documents too, because they're buying a flight that $10 million is still it's funny that that's kind of relatively cheap by launch prices, but it's still a $10 million transaction.
Yeah.
So
do you have any customers?
So right now, we have a little over $1 billion in MOUs and LOIs, but and that's kind of split across like public companies, like private companies, governments, and like other kind of places, and we're really just now looking to like convert those into binding contracts with like actual money down.
Yeah.
And like here's your launch date.
Let's
like
do
we're
this.
building. Yeah. Like let's do
yeah.
this. Yeah. But there's a huge amount of interest. Like actually, a lot of what I'm doing now, besides like leading the engineering, is recruiting, and so including like sales and biz dev, and kind of helping with some of the like requests that now are coming through, because like you said, once we're like as we demonstrate more and more, people are like thinking, okay, wow, like this company is like gonna go launch, so like we need to actually sign up with them, because we're gonna like do one launch first, then like two, and they'll like scale up as far as the frequency of launch. But early on, people actually want to kind of take advantage of the low prices, and like you can develop really good relationships with customers early too. So kind of like SpaceX has done with Iridium, or like Orbcomm, for example, like where they had these kind of early customers that took a little bit of a bet on something that may have been a little less proven initially, but now they're getting like really, really good deals and stuff out of that. So
Build those relationships early. Take them out for a coffee.
There's
or three.
So as far as like, I understand like working with obviously customers, that they're going to be the ones that are going to be going into space and getting the ticket to go. As far as collaborations, there's a question here from LSVH that says, will others with your printer and print designs be able to print the rocket parts as well? I think that more so means it's like, if there's other companies you'll be working with that you'll be giving the printer and print designs to, are you allowing for others to also print rocket parts?
Yeah, right. So not now,
Okay.
is the answer. And we've again gotten approached by like other launch companies even that are like, hey, like can you make our XYZ for our rocket? And again, like while that's very interesting, like our like mission is like we actually want to 3D print rockets on Mars. Like we want to demonstrate that we can 3D print rockets like on Earth orbit first, because actually I think demonstrating that's like with a very small kind of lightweight factory that is like all 3D printers and like mostly automation actually is already kind of a pretty big step to showing that that's possible. And then just getting it to Mars and like designing it for that environment's like the next hard part. But doing it on Earth first, we just want to figure out how to like do that very quickly. Because I think also in the space industry, I mean, since the hardware is so hard to develop, like you can pretty easily get sidetracked to like go this direction or that direction or that direction, and then you end up like everything doesn't like add up to one big like kind of picture in the end. And so we just want to make sure we're like always taking steps towards what the end goal is and like focusing.
Exactly. Speaking of getting sidetracked, there's another funny question I saw in here from Zwebi. They say, what do employees print for themselves at night when no one is watching?
Oh, that's pretty funny. I think someone did some like bottle openers once.
It's
very important for engineers.
Extremely necessary.
Let's see what else.
Have you printed anything when no one's watching?
I printed anything when no one's watching. People are always watching. It's funny, like if you're like,
when is no one watching?
Should have been a CEO.
Yeah, exactly. I was gonna say everyone's always watching when you're a CEO. So, but no, we've done like some other pretty cool stuff.
Like a 3D printing party.
That'd be pretty funny.
What were you gonna say?
Well, I was thinking like someone has a motorcycle, and I kind of wonder if they've printed parts for the motorcycle. But I think it'd be cool.
Would that be like now? Are there any rules against like no printing for personal uses unless you tell us?
No, we don't officially have that rule yet. But I think people are still like pretty like everyone's both like very passionate and they like love 3D printing, and I'm sure they would like love to make stuff for themselves, but they're also like, let's get this rocket developed.
Exactly.
And so they're like, I think our team's pretty like all right, like this is cool stuff, but like it's super cool because like we're gonna make this happen.
And they have the passion, which is amazing. It's so important to have employees that have that passion and that drive as much as you do.
And the skill set.
And the skill set, of course.
The skill set.
Yes, exactly.
Yeah, that's key.
Since you've had a pretty interesting career, I'd say, because you went through USC in the rocket lab, in the rocket propulsion laboratory there.
Oh, nice.
Cool. And and you went to Blue Origin, and then you said, not innovative enough, and you started your own company to make that. What would you say to someone who's going to be getting like their academic career to be an engineer started? What would you say are some of the things that they need to learn to prepare themselves for what's going to be happening with the future of spaceflight?
Yeah, totally. Well, I think one, yes, definitely can answer that. So one important thing to say is I actually originally got into USC for writing, and I thought I was going to be a screenwriter. So I actually dropped that degree like during orientation and just switched to aerospace engineering.
Slight jump.
Yeah,
So.
like before
Very
starting.
minor.
And so that's just important to say because like really even freshman year of school, like, you know, I was kind of like saw this vision of the future where you're gonna like sit in a cubicle and kind of like write some code. Like I was in a MATLAB class, I was just like coding, and you kind of think like, oh, I'm just gonna write some code forever, like in this dark, like dingy office. But then, you know, I was like, all right, like I'll join this thing called USC Rocket Propulsion Lab, where we're trying to actually build and design our own rockets to be the first student group in the world to launch to space.
Exactly, yeah.
And so then with that, I ended up actually, ironically, like writing some of the MATLAB code to like help design the rocket, like and all the flight kind of trajectory planning and stuff like that. And then with that, I was like, wow, like rocket, like code, like writing MATLAB code, like with like an actual application is like super, super cool. And I remembered still like seeing my first rocket engine test, like out in Mojave. We like, you know, did a solid motor, like kind of on the ground, and I think it was like 2,000 pound thrust. But we were like not like super far away, like in a safe distance, but not that far away. And it's just like way brighter and louder than like any YouTube video like ever will really show you. And it's like very visceral. And I think once I saw that, I was like, you know, wow, that is like super cool. So I would, my advice would really be like, you know, having hands-on like experience like in a student club, like
Exactly.
like the best engineers really I know that came out of school, like honestly probably spent like maybe like 40 to 60 almost hours a week, what felt like in the rocket propulsion lab, especially right before a flight. And then like, you know, just tried to like still learn stuff in classes and like get by, you know, enough to like have good grades. But I would say like you could just so clearly tell like all of their passion was not in like sitting in a room like learning the equations, even though people are very good at that, but like more how can we actually like learn what the real like engineering world and stuff is like.
Yeah, we have the other company I work for, so we place students in the RPL and LPL
cool.
at USC.
Oh,
and one
cool.
of my students right now, she literally was just in the RPL like till 4 in the morning.
Yeah.
And like she learned like CAD. She learned like all sorts of neat stuff during this internship. But yeah, absolutely right. Like they easily spend like 40, 50, 60 hours a week just doing hands-on, and that's like outside of the actual classroom instruction.
Yeah.
It's pretty intense.
Yeah.
But worth
it's
it.
intense. Yeah. I mean that, and also too, I mean just USC Rocket. Yeah. Like there's this culture too. So there was this kind of unofficial motto for a long time, which was like space or nothing, and that was
that's
very
so
like
cool.
all in. Where like people were just super
Space or
all in.
bust.
Love
Yeah,
it.
yeah,
Love
yeah.
it.
I mean, there was one time we did like a ground test, and you know, it's like linerless composite case, so it's actually pretty advanced. And it was a big motor, and you know, like the test did not go well, and it kind of like splintered everywhere. And then we were like, oh, okay, like, well, you know, the semester's almost ending, like we need to like make a new motor again, like, but we only have 19 days to do it. Like, is that even possible? When like the first one took like 4 or 5 months. And we were like, all right, we're gonna do it, 19 days. And like we actually built like a new motor, tested it, and it worked like 19 days
Wow.
later, which is like unbelievably crazy.
That is
So I
amazing.
think being part of that culture,
So
or like as a
gritty.
student too, like you just get like super pumped about like the industry, and you kind of see both failure and success like with a very hands-on
important.
thing, and I
Both
think
are
that's
so
very
important.
important.
Yeah, and I agree with that. Yeah. Failure is very important.
Yeah, yeah, especially in the
Yeah.
rocket industry, because I mean, definitely like things will happen. Like, you know, I mean, there's always like challenges in development, and you know, I mean, I can definitely tell you, we do prints that like, you know, the print gets most of the way, and then like something happens and it fails, and you're like, oh gosh, like time to go over again. But you kind of learn each step of the way. You know, same with like even rocket engine testing. I mean, you do, like we've done 100 tests because, you know, test 1 wasn't like, oh, like let's go fly this because we just did one test. Like, I mean, you keep making iterations, and yeah, that's important. So it's also like perseverance, like just don't give up. The second you give up, you've already sealed your fate. But if you don't give up, then
Exactly.
you just at least still keep trying. So.
Exactly.
It's amazing. Wow.
Inspiring.
Yeah.
For engineers and beyond.
Yes.
And I think that's
Wow.
that's a really good note to kind of wrap up After Dark on.
Yeah.
Or at least wrap up your part of After Dark, Tim.
Totally.
And now we're going to do Jade's Space Pod to get that going.
Yes.
Awesome.
So,
Yeah.
there
Thank
you go.
you.
Yeah,
All right.
thank you.
So,
This is awesome.
Donna, what do you need us to do?
I need to borrow Tim for a second to sign a set.
Yes.
Okay,
I'll
sweet.
clear out so Jade has a set to
Yes.
herself.
Very nice.
Thank you.
Awesome.
All right.
And then I just need the chair and the stool, right?
Whatever you want to sit on.
Oh, I can choose.
So we have 2 end caps.
Wow,
You're more
that's
than welcome
awesome.
to sign our set. You
Oh,
have
very
red
nice.
colors.
Oh,
If you got stickers or swag you want to put on it, go for it.
blue. Very nice. Is there like an order that we've got to do
whatever-
it in? Do
whatever
it
you
anyway? Okay.
Find a spot, fill it up.
Awesome. I'll probably do right under this astronaut thing. Oh yeah, and you guys, I saw the launcher guys on here. That was pretty recent.
What's your shirt size?
Medium.
Medium.
Yeah.
The magazine?
EDM.
Oh, EDM. Medium? What? I still haven't heard it. I'm
Yeah,
sorry.
medium. We did have the Bass Nectar song for our.
I feel like EDM's very like rocket appropriate.
Very, yeah. I mean, you've seen
Robot
like.
music.
Yeah, like the SpaceX webcast music is always
Yeah.
like got that tone to it, you know.
Feels good, don't it?
Dude, I know. I just took mine out. I'm like, oh.
I can't wait.
That's
tough to leave
in for almost 3 hours.
Oh, okay, cool.
It does good. So.
David, I brought our setup on over here. If you can hear me.
Nice. Oh,
You got good handwriting. You got good.
me? Yeah, I don't know. Yeah, I was like, my handwriting ain't good. You're the first person that's ever said that. Yeah, all good. Yeah, there you are.
Interesting.
Thank you so.
$10
Oh,
shirt or
oh,
a
it's so awesome. Oh, very cool. Thank you so much.
Thanks for coming.
This is cool. Yeah, I'll have to. We don't even have like stickers and stuff yet, so I'll have to. Since everyone has a bunch of stickers, we'll like make some and ship them over here. I'll drive them over.
Awesome. Jade, you good?
I'm good.
You ready?
Yeah. Yes. Yes.
You need.
Yes.
Can you hear me?
Mm-hmm.
Okay, let's see, I guess. Mute everybody with Jade.
Yeah.
No. The last one. Yeah. There you go. I'll take that. Got it. Thank you. Thank you very much. All right, we're ready.
Okay. Hi. Hello. Oh, let me know when you're. Am I ready? Are we ready?
Tell her.
I couldn't hear you.
We're ready.
Oh, okay. Sorry, I didn't hear anything. Okay. All right. The debate over Pluto's planethood has resurfaced, and some prominent scientists have some things to say about that. This is your Space Pod for Thursday, May 18th, 2018. We all remember what we were doing the day Pluto got demoted and kicked out of the solar system's planet club. This happened after it was reclassified from planet to dwarf planet in 2006 when the International Astronomers Union, right? International I'm just going to say the IAU. Is that okay? IAU.
Are you going to start from the beginning again?
Would you like me to, or would you like me to just start from the story?
Where was she?
I was in the first line after the first graphic.
Yeah, you gotta redo your whole thing. Once you get into the imagery, if you need to cut, you can redo something, just go ahead and redo it and make sure that he's on the right image.
Okay.
Because you're covered.
Okay.
But for the first bit, you have to do that solid.
Oh yeah, no. The first bit where it's just on me, it was after. Yeah.
So
redo the whole thing.
Are you not familiar with the tablet script viewer?
I always forget how to get in there. So, oops, hold on, let me save everything.
So just click on the name on this bit right here, right there, and then tablet script viewer.
Oh, cool. Oh, okay.
And then what I usually do is scroll all the way down, or all the way up, I'm sorry, is the
make it smaller.
And then uncheck everything but the top one. And then the small a to make it smaller so you can readable size.
Oh.
And then you scroll up to where your thing is, and then you're just reading through a script.
Got it. I think it's like the last one here. Neato.
There you go. So you're on this stuff, and this is his triggers for your images.
Okay.
So you have to get through that solid. Once you're in here, you're covered. So you
Okay,
can just
cool.
take wherever you need to.
All right, so redo the whole thing. Okay. Yay, thank you.
Okay, you ready?
All right, yes. The debate over Pluto's planethood has resurfaced, and some prominent scientists have some things to say about it. I'm Jade Kim, and this is your Space Pod for Thursday, May 17th, 2018. We all remember what we were doing the day Pluto got demoted and kicked out of the Solar System's Planet Club. This happened after it was reclassified from planet to dwarf planet in 2006 when the IAU decided it did not meet the criteria to be considered a planet. Well, recently, New Horizons principal investigator Dr. Alan Stern and astrobiologist David Grinspoon recently declared in a Huffington Post article that Pluto's reclassification was, indeed, a mistake. What they are specifically referring to are the 3 rules that the IAU decided up that planets must follow, including having to orbit the sun, being round due to sufficient self-gravity, and to have been able to clear its orbit. And this, my friends, is where Pluto fell short. Pluto actually orbits in a region of the outer solar system called the Kuiper Belt, where it's surrounded by millions of other objects. The quote-unquote demotion had caused an uproar among scientists and the public alike. And these sentiments only intensified after some of the epic data the New Horizons mission has started sending back. You see, for the first time, we're actually able to see exactly how active and complex Pluto really is, from its gigantic icy mountains to its flowing glaciers of nitrogen and so much more. Stern and Grinspoon called IAU's decision flawed and referenced a presentation given at the annual Lunar and Planetary Science Conference entitled A Geophysical Planet Definition. This defines that a planet can be more of a planet based on its intrinsic physical properties over its external orbital properties. If this definition of planet relied more on its physical features versus its orbital ones, then Pluto would definitely have a better chance of being welcomed back into the planet family. As of now, no one really knows if Pluto will ever be reinstated into the mainstream solar system in the planets, but I will say one thing. Don't feel bad for Pluto. You see, Pluto went from being the runt of the planets to being the king of the dwarfs. Basically like going from a tiny fish in a huge ocean to being the big fish in a tiny pond. But no matter how we classify this icy body, we can all agree that nothing will ever change from how captivating this complex world is turning out to be. So be sure to check out the live show where we spoke with Tim Alice of Relativity Space, an amazing interview you don't want to miss. Also, don't forget to like and subscribe, and you can see our shows as we go live every Saturday at 1800 Universal Time. If you'd like to support tomorrow, go ahead and head over to patreon.com/TMRO. Thank you for watching, and as always, stay curious, my friends.
That was awesome.
Thank you. Really? Oh,
Thank you, that
God,
was
I
good.
feel like I was speaking over my... Yay.
fumbled a couple times, but it's
Okay.
awesome.
Nothing will ever beat Tomahawk. I still read the comments on that video just to get a chuckle. But
Everybody good?
I think
I think if you want to sign off for us, I'll hit that.
golden boy. Oh, we're still on.
Yeah.
Hey guys. Sup?
Thank you, Internet. We'll see you next week.
Bye.
Goodbye.
Bye.
Bye.